An electrical contractor licensed in New Jersey is available to assist with projects in the state. The contractor is familiar with New Jersey's electrical codes and requirements. To receive a proposal, provide details about the project including the scope of work, the estimated budget, and the project timeline. This information will allow the contractor to assess the project requirements and prepare a comprehensive proposal outlining the services offered and associated fees. Having a clear understanding of the project scope ensures accurate cost estimation and project planning. Detailing the estimated budget allows the contractor to tailor the proposal to align with the client's financial constraints. Specifying the project timeline enables the contractor to assess feasibility and schedule resources effectively. The proposal will outline the specific services the contractor will provide, ensuring clarity and transparency. It will also detail the associated fees, providing a breakdown of costs for labor, materials, and any other relevant expenses. The contractor can then provide a proposal outlining services and fees. To further elaborate on the process of engaging an electrical contractor in New Jersey, it's helpful to understand the general steps involved in the relevant regulations. Firstly, it's crucial to verify the contractor's license. In New Jersey, electrical contractors must be licensed by the State Board of Examiners of Electrical Contractors. You can verify a contractor's license by checking with the New Jersey Division of Consumer Affairs. This ensures that the contractor has met the necessary qualifications and is authorized to perform electrical work in the state. Secondly, clearly define the scope of work. Before any work begins, it's important to have a detailed written agreement that outlines the specific tasks the contractor will perform. This agreement should include a clear description of the project, the materials to be used, the timeline for completion, and the total cost. This helps prevent misunderstandings and ensures that both parties are on the same page. Thirdly, obtain necessary permits. Electrical work often requires permits from the local municipality. The contractor should be responsible for obtaining the necessary permits and ensuring that the work complies with all applicable codes and regulation. Failure to obtain the required permits can result in fines and delays. Fourthly, understand the payment terms. The payment schedule should be clearly defined in the written agreement. It's common to pay a deposit upfront, with the remaining balance paid in installments as the work progresses. Avoid paying the entire amount upfront, as this can reduce your leverage if problems arise. Fifthly, review insurance coverage. Ensure that the contractor has adequate liability insurance and workers' compensation insurance. Liability insurance protects you in case of damage to your property, while workers' compensation insurance protects you if a worker is injured on the job. Request copies of the contractor's insurance certificates to verify coverage. Sixthly, check references. Before hiring a contractor, ask for references from previous clients. Contact these references to inquire about their experience with the contractor's quality of work, reliability, and professionalism. Seventhly, comply with the National Electrical Code, referred to as NEC. All electrical work in New Jersey must comply with the latest edition of the National Electrical Code. The NEC sets standards for the safe installation of electrical wiring and equipment. Ensure that the contractor is familiar with the NEC and adheres to its requirements. Eighthly, understand ground fault circuit interrupters known as GFCIs. GFCIs are required in areas where electrical outlets are located near water, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electric shock by quickly interrupting the circuit when a ground fault is detected. Ninthly, understand arc fault circuit interrupters, referred to as SIs. SIs are required in many areas of the home, such as bedrooms and living rooms. SIs protect against fires caused by arcing faults in electrical wiring. Tenthly, consider surge protection. Surge protection devices protect electronic equipment from voltage spikes caused by lightning or power surges. Consider installing surge protection at the electrical panel and at individual outlets to protect your valuable electronics. 11thly, understand wiring methods. There are several different wiring methods commonly used in residential and commercial buildings. These include non-metallic sheet cable, also known as NM cable or Romex, which is commonly used for residential wiring. There is also metallic conduit, such as electrical metallic tubing or EMT, which is often used in commercial and industrial applications. There is also armored cable, referred to as AC cable or BX cable, which is used in situations where greater protection is required. 12thly, be aware of grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, while bonding connects metal parts to create a low impedance path for fault current. 13thly, understand overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, protect against overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds the rated value. Fuses are one-time devices that melt and interrupt the circuit when the current exceeds the rated value. 14thly, understand voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or overheat. It's important to size conductors properly to minimize voltage drop. 15thly, consider energy efficiency. When installing new electrical equipment, consider energy-efficient options. Energy-efficient appliances and lighting can save you money on your electricity bill and reduce your environmental impact. 16thly, document everything. Keep a record of all electrical work performed, including permits, inspections, and invoices. This documentation can be helpful for future maintenance and repairs. 17thly, know about electrical panels. Electrical panels distribute electricity throughout a building. They contain circuit breakers or fuses that protect individual circuits. It's important to label each circuit breaker clearly so that you can easily identify which circuit it controls. 18thly, be aware of electrical safety tips. Always turn off the power before working on electrical circuits. Use insulated tools and wear rubber gloves to protect yourself from electric shock. Never overload electrical circuits. 19thly, understand lighting controls. Lighting controls, such as dimmers and occupancy sensors, can save energy and enhance the ambience of a space. Dimmers allow you to adjust the brightness of lights, while occupancy sensors automatically turn lights on and off based on occupancy. 20thly, consider smart home technology. Smart home technology allows you to control electrical devices remotely using your smartphone or tablet. This can include lighting, thermostats, and appliances. These devices can save energy and enhance convenience. 21st, be aware of electrical inspections. Electrical inspections are typically required after new electrical work is completed. An electrical inspector will verify that the work complies with all applicable codes and regulations. 22nd, understand electrical troubleshooting. Electrical troubleshooting involves identifying and resolving electrical problems. This may involve using a multimeter to measure voltage, current, and resistance. 23rd, understand electrical maintenance. Regular electrical maintenance can help prevent problems and extend the life of electrical equipment. This may include inspecting wiring, tightening connections, and testing circuit breakers. 24th, understand NEC Table 310.15. NEC Table 310.15 provides ampacity ratings for conductors. Ampacity is the maximum current that a conductor can carry without exceeding its temperature rating. 25th, understand the voltage ratings for electrical systems. Common voltage ratings for residential electrical systems are 120 volts and 240 volts. Common voltage ratings for commercial and industrial electrical systems are 208 volts, 277 volts, and 480 volts. 26th, understand the concept of grounding electrode conductors, referred to as GEC. Grounding electrode conductors connect the electrical system to the earth. This provides a path for fault current to flow back to the source and helps to protect against electric shock. 27th, understand the concept of equipment grounding conductors, referred to as EGC. Equipment grounding conductors connect the metal parts of electrical equipment to the grounding system. This helps to prevent electric shock by providing a low impedance path for fault current. 28th, understand the concept of bonding jumpers. Bonding jumpers are used to connect metal parts of electrical equipment together to create a low impedance path for fault current. 29th, understand the concept of service entrance conductors. Service entrance conductors bring electricity from the utility company to the building. These conductors must be sized properly to handle the electrical load. 30th, understand the concept of feeder conductors. Feeder conductors carry electricity from the service entrance to the branch circuits. These conductors must also be sized properly to handle the electrical load. 31st, understand the concept of branch circuits. Branch circuits carry electricity from the feeder conductors to the individual outlets and lighting fixtures. 32nd, understand the concept of multi-wire branch circuits. Multi-wire branch circuits share a neutral conductor. These circuits can save on wiring costs, but they must be installed properly to avoid overloading the neutral conductor. 33rd, understand the concept of dedicated circuits. Dedicated circuits are used for appliances that require a lot of power, such as refrigerators and air conditioners. These circuits prevent overloading and ensure that the appliance receives adequate power. 34th, understand the concept of GFCI protection for appliances. GFCI protection is required for outlets that serve certain appliances, such as dishwashers and washing machines. This protection helps to prevent electric shock. 35th, understand the concept of SI protection for branch circuits. SI protection is required for branch circuits that serve certain areas of the home, such as bedrooms and living rooms. This protection helps to prevent fires caused by arcing faults. 36th, understand the concept of surge protection for sensitive electronics. Surge protection is recommended for sensitive electronic equipment such as computers and televisions. This protection helps to prevent damage from voltage spikes. 37th, understand the concept of electrical load calculations. Electrical load calculations are used to determine the size of the electrical service and the feeder conductors. These calculations take into account the anticipated electrical load of the building. 38th, understand the concept of demand factors. Demand factors are used in electrical load calculations to account for the fact that not all electrical equipment will be operating at the same time. 39th, understand the concept of conductor dirting. Conductor dirting is required when conductors are installed in hot environments or in close proximity to other conductors. This dirting reduces the ampacity of the conductor. 40th, understand the concept of conduit fill. Conduit fill refers to the amount of space that conductors occupy in a conduit. The NEC limits the amount of conduit fill to prevent overheating. 41st, understand the concept of box fill. Box fill refers to the amount of space that conductors and devices occupy in an electrical box. The NEC limits the amount of box fill to prevent overheating and to ensure that there is enough room to make connections. 42nd, understand the concept of voltage drop calculations. Voltage drop calculations are used to determine the voltage drop in a circuit. Excessive voltage drop can cause equipment to malfunction. 43rd, understand the concept of short circuit current calculations. Short circuit current calculations are used to determine the amount of current that will flow during a short circuit. This information is used to select the appropriate overcurrent protection devices. 44th, understand the concept of arc flash hazard analysis. Arc flash hazard analysis is used to determine the potential hazards associated with an arc flash. This information is used to select the appropriate personal protective equipment, referred to as PPE. 45th, understand the concept of electrical safety programs. Electrical safety programs are designed to protect workers from electrical hazards. These programs typically include training, procedures, and PPE. 46th, understand the concept of lockout/tagout procedures. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance and repair. 47th, understand the concept of confined space entry. Confined space entry procedures are used when working in confined spaces that may contain electrical hazards. 48th. Understand the concept of electrical shock hazard. Electrical shock hazard is the risk of injury or death from electric shock. This hazard can be minimized by following safe work practices and using PPE. 49th. Understand the concept of arc flash hazard. Arc flash hazard is the risk of injury from an arc flash. An arc flash is a dangerous electrical explosion that can cause severe burns and other injuries. 50th. Understand the concept of electrical fire hazard. Electrical fire hazard is the risk of fire caused by electrical problems. This hazard can be minimized by following safe wiring practices and using overcurrent protection devices.